Hello, I'm Ryan from Buster Beagle 3D. I recently put out a video with resources to look into when making molds for the Buster Beagle 3D injection molding machine. I linked to where I get my materials for cheap and tutorials to check out to help make the molds. The feedback to that video was that while it was useful, people still want to see how I make the molds. Well, today I'm going to show you how I cut aluminum injection molds on my 3018 Pro CNC machine. Now, here's the big disclaimer. I do not claim to be an expert in CNC, but as a tinkerer, I just wanted to show you how I was able to do it. I am a 3D artist who comes from almost a 20-year background in the video game and VFX industries. Because of that, I create my 3D models in a polygonal modeling package like Autodesk Maya, 3ds Max, and Blender instead of a parametric modeling package such as Fusion 360 or Tinkercad. All of these programs will output STL files, which is what I'll be using. I'm also not going to go into how I model the files in this video, but focus on the CAM or computer-aided manufacturing portion of the process. This one might be long. Are you still with me? Well, let's get started. First, I wanted to go over what I'll be using. Again, I will be cutting this on my hobby grade 3018 Pro CNC machine with one modification. I have upgraded to a 52mm 500 watt spindle with an offline speed controller. I also created a vise that I use on the machine that helps with the probing of the X, Y, and Z position of the part that I want to cut. You can find a link to that video in the description. Everything else on the machine is stock, with no upgrades to the frame or stepper motors. The CAM software I'm going to use is called CAMBAM. Now, CAMBAM is not a free piece of software, but they do offer a very generous 40 uses trial to check it out. And by uses, I don't mean days, but uses. That means a use counts for every time you open the program. If you're like me and never turn off your computer, then as long as you have it open, it's one use. And if you like this software, consider picking it up as it is not that expensive. I know that Fusion 360 is free to hobbyists, but I find CAMBAM to be really easy and have much less of a learning curve. So like I was saying before, I don't use something like Fusion 360 to model. I use a polygonal modeling program called Maya. You can use Blender, there's free versions of something like this. Really all you need is a program that can export STLs, so anybody who comes from 3D printing would be very familiar with exporting STLs. So this is my model. Right here I have it kind of set up inside of my vices just so you can kind of see how I'm going to orient it. And then right here in the bottom corner is actually the origin. So going up is actually the y-axis, side to side is the x, and then going in this direction would be the z. So this is 0 down here. Now if you look, I have my other side of the mold, but I'm going to focus on this one for right now. So what I want to do is I want to take this mold and I want to export an STL of this file. Now there's a few more things that I'm going to want to need from this program. I also want the outlines of all of the flat areas of this mold. So I've gone ahead and made them all in the same plane, but if you have multiple areas in different planes, that's okay too. I just wanted to have to export this out a single time. So I exported this single plane, which is just a flat plane, out as a separate STL as well. I also already kind of figured out where I want to have my sprue hole, so I've already also added an STL of that. You can do it in the other program, but since it's already here, I just might as well put it together. And then the very last thing that I'm going to add is this text for some engraving that I'm going to use later. And I will show you how to use all of those. So I'm going to open up CAMBAM, and you can see this is what it looks like when it opens up. Now, one of the first things that I actually like to do is I like to actually save my file. So right now I'm just going to call it Heart Mold. And the reason I name it is because when I actually export out the G-code, that'll be part of the name of the G-code. So then I'm going to come up to here where it says Import Surface Mesh. I'm going to click on it. I'm going to navigate to the folder where I have all the files. I'm going to select Heart Mold, hit Open. Now you're going to see it pop up in the screen. If you hold the middle mouse button, you can pan from side to side. Scrolling the middle mouse button will zoom in and out. And if you hit Alt and left mouse button, it'll actually rotate around. I'm just holding down Alt and left mouse button to do that. Now, if you get to the point to where something just gets lost and it's off screen, you can't find it anymore, just come up here to View and Reset, and it'll put it back in your view. Now, if you want to turn off the grid, you can just come up here to show or hide the grid and turn it off. But this is my model. So I am actually going to click on the layer up here that says Default, and I'm going to rename it Model. Okay. Now I'm going to create a new layer, and I'm going to call this one Outlines. Now you see this little triangle next to the layer? That's what's set as the active layer. So anything that you bring in right now will go in that layer. If I wanted to go back here and add something to this layer, I just click on it, right click, and set as active layer. And you'll see that that little triangle moves to the other layer. I'm going to come down here back to Outline, set this as the active layer. And now I'm going to import the outlines that I was showing you before. So I'm going to come back up to Import Surface Mesh. I'm going to hit my heart outlines. And if you click on each of the surfaces, whatever you have selected will turn red. And the reason that I put these in different layers is so that I can actually hide each one individually. So if you come up to the layer and you hit spacebar, that layer will turn on and off if you tap spacebar. Then I come over to Outlines, tap it on and off, it'll hide the layers. Okay, so now what I'm going to do, right now I'm just going to hide the outlines. So I have this mesh. Now you have a couple of different ways to do different cutting operations up here. The first one that I want to do is I actually want to cut out the main section of this circle here. So I'm going to select Surface. And the one that I'm actually going to be using is 3D Profile. Now, a lot of you might think that maybe I can use a pocket for the initial cut of this, but you have to remember that there's a draft angle on this model, so the actual walls of this are not actually 90 degrees. There's about a 3-degree angle to these, and the reason that you want to do that with injection molding is you want to make sure that you have that drafting angle in there that'll allow you to actually demold the part. And you certainly don't ever want anything that's actually undercut. So I'm going to choose 3D Profile, which is this little cylinder right here, with the actual surface selected. Okay, once I do that, I'm actually going to get a part under the Machining tab here that'll say 3D Surface. So the first thing that I do is I scroll all the way to the bottom, and I know that I want to use a 1/4 inch end mill on this. I have a larger cullet on my 3018 Pro, which allows me to use the larger bit. And because it's larger, it's obviously going to clear more material all at once. So I always like to start with that as my first operation. So I'm going to come to Tool Diameter, and this is all in millimeters. So a 1/4 inch in millimeters is 6.35. And then down here for Tool Profile, I'm going to choose End Mill. If I just come up here and I hit right click on the 3D surface and hit Generate Toolpath, you'll see that it's cutting over the entire surface. But that's not what I want to do. I actually want to keep it within this area. And again, if you want to hide any of the toolpaths, you just click on it and hit spacebar, and that'll hide that toolpath. So what I want to do is I want to limit it to only the area inside of this circle. So that's why I have these outlines here. So if I choose this outline, and then I go up here to Edit, Surface, Silhouette, I'm going to leave this as default, hit OK. And so what this has done now is it's taken this surface and it's created polylines for each of the outlines of this model. And so actually what I'm going to do is I'm going to create a new layer, and I'm going to call this Polyline, and then I can select and then shift select the rest of them and actually just drag them down onto here. And the reason I'm doing this is so I can take this outline and now hide it. So right now I see my surface, and then I see each one of these individual polylines. So if I go back to the part that I created an operation for, I'm going to click on that. And down here under boundary method, I'm going to hit shape outline and click selected shapes. Now if I come back up here to the polylines, I see that polyline 5 is the one that I want to cut inside of. So I'm going to come back here. I'm going to go back to selected shapes, and then the boundary shape IDs right underneath it, I'm going to type in 5. Okay. Actually, I'm going to unhide those lines. Now if I was to run the generate toolpath on this again, you'll see that it's now inside the boundaries of that selected shape 5. Okay. Now right now, this 3D profile method is set to horizontal, but I want it to cut around. I don't want it to cut horizontal or vertical. I want it to actually cut in a circular shape. So I'm going to come down to the 3D profile method. I'm going to select waterline rough. I'll generate toolpath just to show it to you. So right now, this is going down as far as that particular bit will allow it to. So it's not getting into any of these deeper grooves because the bit is too thick for that. I'm going to come down a little bit further, and the depth increment, because this is a hobby CNC machine, I don't like to push it too far. So I like to keep my depth increments to 0.1 millimeters. And then I'm going to come down here to cut feed rate, and I'm actually going to change that to 100, and my plunge feed rate also to 100. Because I have an offline speed controller, I don't really need to worry about this spindle speed because I actually adjust my spindle manually. But what I do have is a fan off to the side that's actually hooked up to the spindle connection on my motherboard, and I use that to kind of clear the chips away. So I'm just going to crank that up to 20,000 because I just want it to turn on the fan. This is not what you have to particularly set this on for this particular cut. Again, I'm using this for the fan, so that's why I'm setting this to 20,000. I'm going to cut this around 9,000 RPMs on my spindle. So I'm going to come back up here. I'm going to generate toolpath, and then there we go. So now you can see these lines are much closer together because right now this is only going down 0.1 millimeters, whereas before it was going down 0.4 millimeters. So it's going to make more passes, but you know, on a machine like this, I don't like to go too deep because you get a lot of chatter, and this is not really a super robust machine, so I find that 0.1 works very, very well for aluminum. Okay, so now that I have my toolpath, what I like to do is click on this and actually name it something. So I'm going to call this rough pass, and then in here I actually like to include in the name the actual bit that I'm using for this, so that later on when I'm going to actually run the operations, I don't have to guess what I was using for this particular toolpath. So this will be 635 for 6.35 millimeters or 1/4 inch, and then I will call it EM for end mill because this is going to be using a flat end mill. So I'm going to hide this right now. So the next thing that I want to do is there's this deeper section around the edges, and the 1/4 inch end mill won't fit down into these. So I'm going to use a smaller bit to be able to get down into these sections. So I only want to run this operation inside of these two lines because I don't want it to cut into anything else just yet. I'm really concerned about roughing out this shape, and then I'll go back into the hard later. So what I want is I want this section and this section. So I'm going to take this polyline 5 and polyline 6, and right now I'm just going to copy them and then paste. So you'll see I have 5 and 6, which are the same as 9 and 10, but I'm going to choose 9 and 10. I'm going to come up to Edit, hit Convert To, and then I'm going to convert it to a region. Instead of polyline, there's 2 polylines right now, I'm going to convert that to region. So right now, I just have one region, which is just this section and around the base of this coin. So I'm going to go back up to Surface, and again I'm going to choose a 3D profile, and then this one I am going to just name it first. I'm going to call it Outline Circle. And then I'm going to be using a 2.5 ball nose for this one. Okay. So like I said, I'm going to come down here to the tool diameter. I'm going to change this to 2.5. My tool profile on this one is going to be ball nose. Come back up to the top here. I'm going to change my cut feed rate back to 100. My plunge feed rate to 100. Again, I'm going to come down here to the spindle speed, and I'm going to change that to 20,000. And again, this is controlling my fan. This is not controlling my spindle. If this is controlling your spindle, you want to set your actual spindle speed here. And again, I'm using about 9,000 RPMs for that. Okay. So under the boundary method, again, I'm going to choose selected shapes. And because I now have this region 11, I'm going to type 11 in here. So now I'm going to generate toolpath. Again, I want to choose the Profile 3D method of Waterline Rough. Come up here, generate toolpath. Okay, so now you see I have a toolpath that's going to go just around in that kind of gully I have around the coin. But as you can see here, it's cutting all the way from the top all the way to the bottom. Well, I've already cut from this point to this flat area right here, so I don't need to cut any of these other sections. So the same thing with the rough pass. I actually don't want the rough pass to cut into the heart. So I happen to know that this initial space is 2 millimeters. So for the rough pass, I'm going to take that and then come down here where it says target depth, and I only want that operation to go down that -2 millimeters. So if I was to generate the toolpath, you'll see that this toolpath no longer goes into this heart groove. Now again, if I come up here and I hit model and then spacebar, I can hide that geo. But you see, it's only doing a circular pass. You don't see it going down into that heart anymore because I want to use a little bit of a finer tool for that heart anyway. I don't want to clear it out with such a large tool. So I'm going to bring that model back by pressing spacebar. On the layer, not the surface, but the layer, hit spacebar, and spacebar will hide and unhide. Okay, so the same thing goes for this outer ring. I don't need it to start up here because it's just going to be cutting in air. So what I want it to do is I'm going to take this outer circle. I'm going to come down here to where it says stock surface, and I'm going to set this to -2. So if I come back here and generate the toolpath, it's only going to cut from -2 down. So it's not going to cut in the air a bunch until it gets down to that surface. And it just kind of cuts down on general operation time. So the next thing that I want to do is actually cut out this heart section. So I'm going to hide these 2 polylines right now. I'm going to come back up to surface. Again, I'm going to choose my 3D profile. And I'm going to clear this out. I'm just going to call it heart. And then I'm going to clear this out with a 3.175 ball nose end mill. Okay. So I'm going to scroll to the bottom, go to my tool diameter, change that to 3.175. Go to my tool profile. I'm going to change that to ball nose. I'm going to come back up here, change the horizontal to rough in the profile 3D method. And now I only want to cut inside of this heart, which happens to be polyline 8. So I'm going to come back here, choose the boundary method, change that to selected shapes. Boundary shape IDs, I'm going to change that to 8. I'm going to come back to the depth increment. I'm going to change this to 0.1. Now, I know that that first roughing operation brought it all the way down to -2 millimeters. So I'm going to change the stock surface to -2. Now, one thing you need to kind of be careful about if you change the stock surface is this is where it thinks your material actually starts. So if you start your end mill at your origin and you say, oh, the stock surface actually starts 2 millimeters underneath that, you kind of run the risk, if you start the operation from here, of actually dragging into your piece. So when you start to use stock surfaces below the actual surface of your part, you want to move your end mill over above that section before you start your operation. And then that way you don't run the risk of actually dragging your tool into the model before it actually starts cutting where you want it to. So I'm going to hit the stock surface as -2, change my cut feed rate to 100, and my plunge feed rate to 100 as well. Because this is a roughing operation on a kind of like 3D part, I wanted to leave just a little bit of material for further cuts. So what I'm going to do is come down here to where it says roughing clearance, and I'm going to actually put this to 0.2 because I'm going to run another operation after this that goes down just a little bit further than this one does. So this is going to leave 0.2 millimeters of surface on this heart with this cut. So I'm going to come up here to generate toolpath. So now as you can see, it's doing the cut, but it's only doing the cut inside of this heart, which is exactly what I want. Now, like I was saying, I'm going to use this larger 3.175 ball nose. So for the next pass of this, I'm going to use a smaller ball nose end mill to just get a little bit more detail on this part before I do my final finishing run on here. So instead of going through that entire process again, what I can do is right click on here, hit copy, and then right click and paste. And so I'm going to change the name of this one to going back to use that 2.5 end mill, so 25 ball. Okay. So now if I scroll down to the bottom, I'm going to change that to 2.5 millimeters in the tool diameter. So on this particular one, I'm going to change the roughing clearance to 0.1. So this way it'll go 0.1 millimeters further than this heart operation that was a 3.175 ball nose. So if I click on this one, you see it has a 0.2 millimeter clearance, and this 2.5 ball nose has a 0.1 millimeter clearance, because I'm still going to do another pass over this to make it much smoother. Now for this second operation, what I want to do is I want to be sure to actually cut all the way down to the surface with that roughing clearance 0.1, and I have to scroll back up to the top. Now for this depth increment, I no longer want it to cut to 0.1 because I want it to go all the way down to the surface. So I'm going to change this to 0. Now this particular thing doesn't seem to work with the rough outline operation, so I'm going to come back up here to where it says waterline rough, and I'm going to change it to horizontal, so it's going to go in this direction. And then if I come up here and generate toolpath, it's going to go the entire direction down to that surface minus that 0.1 roughing clearance down here. Now, right now it's going to all go in the same direction. If I wanted to cut and then cut in the other direction, so if I wanted to go both ways, right here where it says milling direction, I can change it from conventional to mixed. Generate toolpath. And as you can see, It's going to go in one direction, the other direction. So this is just going to give me a little bit of a closer cut on the next pass. Now, if I wanted to increase the resolution of this just to make sure that my finishing cut has more of a final surface to deal with, I can come down here to where it says step over. So what the step over means is it's going over basically 40% to the next line. So it'll come over, it'll go over 40% of that tool diameter and come back the other way, go over 40% of the tool diameter and go the other way. So if I come down here and I change that number to 0.3 and then I were to generate the tool path, you'll see that those lines are much closer to each other. So this is kind of how you increase the step over, or how close these things are cutting to each other. Now if you put this to something really high or really low like 0.1 and generate the tool path, you'll see you really start to cut over these lines. So what I'm going to do for this particular one is I'm just going to go to about a 0.3 where it was set to 0.4. I'm going to generate the tool path, and it's going to cut out this heart in just a closer area. So again, by changing the depth increment to 0, it'll go all the way down to the part. I still have the stock surface set at -2, so it'll start around that area. So the next cut that I'm going to do is a finishing pass that goes over just this section of the heart. So I'm going to come back up to my surface. I'm going to hit 3D profile, and I'm going to call this one finishing. And for this one, I'm going to use a 40-degree V-bit. So V-bit. I'm going to scroll down to the bottom. And then for tool diameter of a V-bit, if you select these tool numbers, you'll see that they have some already in here. I find that this V-cutter works just fine. You can set up your own tool numbers that you use, but I find that this one just works. So it's going to select the tool number, which is 10, which is setting up as a V cutter. So I'm going to come up here. So I know I don't want to cut into this outside area anymore. So I'm just going to cut into this polyline 6. So I'll come up here, hit shape outline, selected shapes. This is polyline 6. And on this one, I actually want to cut it in the horizontal. So horizontal is fine. I want this to go down the entire way to the surface because this is going to be my final cut. So the depth increment I will change back to 0, so it goes the entire way to the piece. Again, I'm going to change this to 100 and another one to 100. So on this particular one, I'm going to keep the step over right now to 0.4 because a little bit of insider baseball here. I've already cut this part, so I'm doing this after I've already cut everything. So I know what I end up doing is I end up cutting over this entire part, and then I realize that I want it to be a little bit finer, so then I cut in the vertical as well. So I'm going to keep the step over there as 0.4, which is just fine. So if I come up here and generate toolpath, there we go. So it's going to cut over this entire part. So for my final pass of this heart, what I ended up doing was after I cut along this way, I ended up cutting in the vertical too. I wanted the resolution to be higher, so what I will do here is I will take this finishing V-bit and I will copy it and I will paste it. So I have this new finishing V-bit. And I'm going to call this one final. So on this one, instead of going horizontal, I actually want to go vertical. Oh, in the first finishing V-bit, I also don't all cut in the same direction. I cut forwards and backwards. So to do that, again, you want to come over to where it says conventional, and I'm actually going to set that to mix. So it's going to cut in both different directions. So for this final V-bit, I'm going to do the same thing. I'm going to cut it as mixed. Now, let me hide the one before it. And I'm going to generate the toolpath. So it's cutting in the other direction, but what I want is the resolution to be much, much higher than the one before it. So I'm going to come down here to where it says step over, and I'm going to change that to 0.1. Now, because I had already cut the finishing V-bit down to the surface, what I ended up doing was tricking my CNC machine into thinking that the Z-axis, or the origin point, was 0.05 millimeters below where it actually was. So I left this at the roughing clearance, which is going to go all the way down to the surface, but in G-code sender, when I homed my device again, I then dropped down the Z-axis another 0.05 millimeters so that it now thought that the surface was a little bit lower. Now, because this is cutting such a small amount, what I ended up doing was I increased my cut feed rate up to 500, and the plunge feed rate to 100 is fine. So this is going to cut much, much faster across the part, but it's cutting into it. It's such a minuscule amount that the machine can handle it without any problem. Okay, so here are all of the operations for that particular inside of the coin. So now what I'm going to do is I'm going to select this Polyline 3 and Polyline 4. I'm going to select both of them together. Okay. And then over here, I'm going to hit drill. So now this is going to create a drilling operation that works with both of these. So over here, I'm going to change this to drill is fine. And I'm going to do this with my 3.175 end mill. So I'm going to scroll down to the bottom. Tool diameter 3.175. This is an end mill. Now the block that I'm using is a 1/2 inch thick, which is 12.7 millimeters. So when I come up here to my target depth, I'm actually going to set that to negative 13.1. I do that just because I want to make sure it cuts just below the surface and punches all the way through. Now on operations like this, I actually increase my cut feed rate up a little bit. I'm going to cut this at 200 because whenever you're cutting something, and this is going to be straight down, whenever there's more surface area touching a vertical wall, it has a lot more potential to grab the edge of that wall and shatter. So I like to do it just a little bit faster to get through this whole surface. I'm still going to change the plunge feed rate to about 100. Okay, so you can already see, here I'll hide the surface. You can already see that it's going down, and then it's going down on the other side. So if I were to generate the toolpath, it's going to cut down, come up, go to the other side, cut down. Okay. So that's how I'm going to cut my dowel pin holes. Now, one thing to mention about these dowel pin holes is you want to measure the diameter of the dowel pins that you're using. And then what I like to do when I created these holes was I created them at a diameter of 0.4 millimeters smaller than the diameter of the dowel pins. And this is because on one side of your mold, you actually want to press those dowel pins in so that they'll never come out. You don't want it to where they can move loosely around inside of your part. So what I would recommend is subtracting 0.4 millimeters from the diameter and then cutting your holes at that size. Now, I would also recommend that when you do this, you cut the first half of your mold with that particular size lower, and then you'll cut the second half of the mold with the diameter exactly the same diameter as the dowel pins, because you'll still have like a little bit of play in there from these machines. But you want to try to do the smaller hole first, because if you screw up, then you can try to do the smaller hole on the second piece. But you're going to be out of luck if you cut both sides of the mold and you hadn't made a smaller section. So again, try to cut and press in the dowel pins in the first half of your mold before you cut the second half to make sure that these holes aren't too large. So there are my dowel pins. So the next thing that I'm going to do is I'm going to come back up here to outlines. I'm going to set this as my active layer, and I am going to import my heart sprue. So here's another model that I have. Now, this particular model that I brought in, I already know is 3.175 millimeters across. Now, you could do the same thing in this program. So if you come up here, I'm just going to reset my view. So if you come up here to where it says draw rectangle, you can click on that, and you can actually draw out your own polyline. So if you don't want to even create these dowel pin holes using an STL, you can do it with the regular CAM tools that are up here. We have Polyline, you can draw a circle, and you can add text. You can do all kinds of stuff inside of this program as well. I'm just really showing the way that I do it using an STL. So I deleted that. So I'm going to come back here to this new mesh that I have, and I am going to come up to Edit, Surface, Silhouette, keep the files the same. Okay, so this is Polyline 14. I'm going to drag it into my polylines, click on Outline Layer and hide. So for this particular operation, what I want to do is I want to cut back and forth in this area with the 3.175 ball nose, but I only want to go down half of the diameter of the ball nose that I'm going to use. So if it is 3.175 divided by 2, I only want to go down this distance. And that way it creates kind of a semicircle, and then the other half of the mold will have the other section of the semicircle, and that way I'll just get a really nice small sprue hole, and this way it'll be like the beginning of the connection that I'm going to use to inject the plastic. So I'm going to take this polyline here. Now on this particular operation it's okay to use a pocket because it's just a straight line. So I'm going to hit pocket. I'm going to change this to sprue 3175 ball. Come down to the bottom. Tool diameter is 3.175. It is a ball nose. Again, 100 for the cut feed rate, 100 for the plunge feed rate. I'm going to come back up to the top. So I want it to be half of the diameter of the tool that I'm using, which was 3.175. So this will be negative 1.58. I will generate the toolpath. There we have it. It's going to cut right through that section at a target depth of negative 1.58 millimeters. Okay, so we're almost done. If you notice on the part, I actually have Buster Beagle 3D written on this surface. So what I ended up doing for that, I'm going to hide all of these. Again, spacebar to hide. I'm also going to hide my polylines right now. So I had another STL. I'm going to go grab that. I'm going to go up to Outlines. Show it again. I'm going to go back to Import Surface Mesh. I'm going to go to Heart Text. Okay. And with that selected, you can't see it because it's underneath this other polyline. So for engraving, you want the engraving to be right on the surface of the model. You don't want the engraving up higher like this particular outline is. You want it to be right on the surface. So I'm going to go to Edit, Surface, Silhouette, and hit OK. So it's created all of these polylines that are right on the surface. So I'm going to select all of these polylines. I'm going to come over here to engrave and hit engrave. All right, I'm going to hide these outlines right now. Okay, so I'm going to change this. Now I can do this a little bit faster because again it's not cutting in very deep and the machine can handle it. So I'm even going to do this up at 300. My plunge feed rate would be 100. I'm going to use that same V-bit I used for the finishing pass. So I'm just going to select it in here again, this V-cutter. I'm going to scroll up. Now the target depth that I want to do on this is I just wanted to do a very light engraving in the surface. With the injection molding machine, you will see every surface detail that you have on this model. Even a minute 0.1 millimeters will still show up. So I'm going to set my target depth to a negative 0.1 millimeters. Okay. So I'm going to generate that toolpath. I'm going to hide the model so you can see it. And so it's just going to go in and cut this. And again, you want it to be a inverse of your actual text, because when you actually shoot in the mold, you're going to get the inverse of that model. So it's going to cut like that, and that'll be my engrave. And I'll say engrave, V-cut. Okay. The very last line that I want to do is actually to create some air vent holes, so when I inject the plastic, there's a place for the air that's already in the cavity of the mold to escape. So you want to cut some shallow lines so that the air can escape, but not big enough so that the molten plastic can also go through. So an easy, quick way to do that is to come up here to Polylines, and then I'm just going to click down here, come off to the side a little bit, click up to the top, and then click in just around till it gets to where the coin is again. And then I'll press enter. Here's the polyline that I just created. There it is. I can run a profile operation on that. I'll just click profile. And on this one, we're just going to keep it real simple. I'm just going to use that 3.175 end mill. And then as far as the depth is concerned, I just want to put something very, very shallow. Again, it's really just there so that the air can escape, but you don't want it so deep that the molten plastic can go through. So I'm just going to go down 0.05 millimeters. And the target depth would also be negative 0.05. Speed 100. Plunge feed rate 100. And then I'll generate toolpath. And again, it's just a single line that's going to go over this poly line that I created. And it's just going to cut out a very, very thin groove there. So I'll just call that air vent. Okay. So there we have it. There are all of the operations that I'm going to use to cut this particular mold out. So before we actually export any of our G-code out, if you have the same 3018 Pro CNC machine that I have that running Gerbil, you might want to make a couple small changes to this program before we actually export. So right now we've been working in the Drawing tab. If you come over to the System tab, you want to make sure that Gerbil, at least for me, is the thing that I'm using. It's the post-processor that I'm using for this machine. But even this, I want to change a few small things. So if I scrolled all the way down to the bottom here to where it says Tool Change, now I'm not doing any automatic tool changes on my machine. I'm going to do them all manually. So if I click on this 3 dots right here, you'll see actually going to add this M6, which is the tool change. So I'm just going to delete that because I don't want it anymore. I'm actually just going to put a pause of M5 in there. So I'm going to delete that last line and put M5. Hit OK. Now, I believe I was also getting some errors from this minimum arc length. I think I had to add a couple of zeros to this so that I didn't get any errors. So I changed the minimum arc length to 0.001. And then I also believed that I ended up changing this distance incremental to G91.1. So you might not have to do this, but if you're running into error in G-Code Sender, you might want to come back and change some of those settings over here. Okay, so we're going to go back here, we're going to right click and produce G-code on all of these, and we're going to save through the whole lot of those. So I've gone through and I have saved all of these out, and so now I'm going to open up Universal G-Code Sender. So the first thing I want to do is actually connect to my machine. Okay, we're all connected. Now, if you're like me and you're using the larger spindle, what you want to do is actually make a change in your firmware to make sure that you never have the Z-axis slipping. And what I mean is there's extra weight added onto the Z-axis. So after you finish a cut and the stepper motor turns off, there's a tendency of that extra weight to actually make the Z-axis drop a little bit. So when you go back and you think that you're at 0, you're not at 0 anymore because the tool has dropped. So what I like to do is I like to come over to the firmware settings, and the value that you want to change is this $1 to 255, and what that's going to do is it's just going to make sure that your stepper motors are always engaged. That also means that you're not going to be able to move any of them by hand, but that's okay. It's not going to add any extra heat or anything like that to your stepper motors. They can handle it, but it's a way of making sure that you don't have any of kind of that slippage from the extra weight. Save that. Okay. So at this point, what I end up doing is I end up using this probe module, and the vise that I have on my machine actually allows me to probe the part itself to find the origin point. Now I'm going to list a link to a video right here where you can show how I do this. I'm not going to go into it right now, so if you watch this video you'll see how I actually probe the part for the X, Y, and Z origin of it. So the first thing that I'm going to do after I probe the part is I'm going to open. So I'm going to find the first operation, which is my rough pass 635. Open. There we go. So there is my operation. And then I'm just going to run it. Now, one thing that you don't see in this video, because I ended up not doing it for this half of the mold, but I ended up doing it for the second half of the mold, which I'm not showing, is I use a little bit of this Tap Magic cutting fluid. I just found that especially on these machines, it really helped to reduce down the chatter and make for a much nicer, smoother cut. It was something that I ended up doing on the dog half of this mold, and it really helped with the quality of the mold. Okay, so now that that operation is done, what I'm going to do is I'm going to manually change the tool. Now this time when I run that same process for finding the Z, I just change my settings here to Z, and then I initiate the probe, and then that will find the new Z height of the tool. I don't need to change the X, Y, and Z because as long as I haven't turned off my machine, it already knows where the X and Y is. It just doesn't know where the Z is of my new tool. So I don't ever touch the X, Y, and Z again unless I run another operation, or if I have to go back to the part, then I'll run that. But for between each operation, I'll just do a Z probe of the part. So now I'm going to load my next pass, which is this outline circle, and I'm going to run it. And so I'm going to do this for each of the different passes that I have. I'll cut the path, I'll bring it over to the side, I'll change out the tool, bring it back, initiate the Z, and then I'll kind of like move the tool over the section of where it's actually going to be cutting, because again, on some of my operations I set the depth to below the actual real surface of the model. So I want to make sure that I'm never dragging into the part when I'm doing my cutting. So when I was talking about that final pass that I ended up doing on this part, I said that I had to go down to that surface, then I had to trick the machine into thinking that the surface was a little bit higher than it actually was. What I'll do is I will return to 0 on my bit, and then I just moved it out to the side. And then over here on the step side Z, I just changed it to 0.05, and then I just selected the Z negative and clicked it once. So if you see here, this is now pretty much set to a negative 0.04. So now it's below the actual surface. So then I just take this and I zero it out. And so now the actual surface is 0.05 higher than the actual tool, but the machine doesn't know that. So then what I'll do is I will take this, move it up, and bring it back over to this area where I'm going to start cutting from. I then take my mold, put the two halves together, and place it in my vise. What I want to do is add a larger connection for the nozzle for the injection machine to be able to sit inside of. For this, I ended up using a 1/2" drill bit to cut a nice little half dome out for my nozzle. I then heat up the injection machine. I like to place the mold on top of the chamber while it's heating up to also heat up the mold. After the machine is preheated, I clamp the mold together with some C-clamps, place and shoot my part. Remove it, place more plastic in the chamber, remove the part from the mold, put it back together, and then shoot again. So that's it. Congrats, you made it all the way through. I know it was a trek to get here. Thank you so much for watching, and if you want to see other, hopefully shorter videos dealing with injection molding, CNC, 3D printing, and others, please do consider subscribing and liking the video. It really does help me keep going. Thanks again, and we'll see you next time.